Okay, so this will be a really quick lesson regarding logarithms. And what's important for us to understand, the major thing to understand, is that we've been studying equations that are in the form y equals kx, where y is my output, k is my base, and x is my input. And that function is an exponential function, and that is in exponential form. Well, the inverse of that function is logarithm. And in terms of the same x and y and k, the logarithm of base k of y will equal that same x. This is logarithmic form. And what's going on here is that these are inverse functions. In other words, the output of the exponential function can be the input of the logarithmic function. The input of the exponential function can be the output of the logarithmic function. So the x's and y's, as we've talked about with inverses, switch. So they are switching, their job being the input and the output. So what that means is, if I have an equation 4 to the third equals 64, that is written in exponential form. I can write a logarithmic equation with those same numbers by writing log base 4. So those bases need to remain the same, but this time it's going to be of 64 equals 3. So those are two equations. One is written in exponential form, one is written in logarithmic form, and they say the same thing. So just being able to go back and forth between these two forms is very important, because that now allows me to solve equations that look like the following. If I have log base 2 of x equals 3, well, I can write that in logarithmic form by writing 2 to the third equals x, and I know that 2 to the third is 8, so I know that when I solve this problem, that x must equal 8. And I discovered that just by writing it in exponential form. I can put my x in a different place. So for example, my base of x to the first power equals 2. Well, what to the first power equals 2? In this case, x must equal 2. And if I wanted to, I could even put my x as my output of the logarithm. So I could write log base 4 of 16. And in that case, I have 4 to the x power equals 16, and I know that x would have to equal 2. So for starters, one of the things that we're doing with logarithms is just rewriting from exponential form to logarithmic form, and in some cases solving for some x in a logarithm. So that's all that we're really doing here, and just utilizing this form of an exponential function.